There is something different about the world at night when it rains. The streets become quieter. The lights outside soften behind the glass. Cars pass occasionally in the distance, their tires moving gently across wet pavement. And above everything, the rain continues, drop after drop, almost as if the night itself is breathing. For a moment, there is nowhere else we need to be. No destination, no schedule, nothing that needs to be solved. Only this quiet room, this rainy night, and the sound of water falling onto the world outside. Imagine sitting beside a window. The lights of the city are scattered across the darkness. Some buildings are still awake. Others have already gone quiet. Millions of people are sleeping. Somewhere, a child is dreaming. Somewhere else, someone is finishing a late shift. And somewhere beneath another roof, another person may be listening to the same rain. The world feels enormous, but from where you are sitting, it also feels very small. Just a room, a window, a little warmth, and the sound of rain. Yet, beneath that quiet moment, an entire planet is moving. The earth is turning beneath your feet, slowly, silently, carrying cities, oceans, forests, and mountains through the darkness. We rarely notice it. The ground beneath us feels perfectly still. The buildings do not seem to move. The trees outside remain in place. And yet, the entire planet is rotating through space. At the same time, the Earth is traveling around the Sun, and the Sun itself is moving through the Milky Way. So, even while you sit completely still, you are already traveling through the universe. You have been traveling your entire life. You simply never feel the motion. Outside the window, the rain continues. And, perhaps, for a moment, look at the drops themselves. They seem ordinary, water falling from the sky, something we have seen countless times. But even the water in those drops has a story. Some of it may have traveled through clouds. Some of it may have flowed through rivers. Some of it may once have been frozen inside a glacier. Some of it may have been inside an ancient ocean. And some of those molecules may have existed on Earth long before human beings ever appeared. The water falling tonight is part of an ancient cycle. It moves from ocean to atmosphere, from atmosphere to land, from land back toward the ocean. It changes form, it evaporates, it condenses, it falls, and begins again. The Earth is full of cycles like this, but the planet itself is also part of a much larger cycle. A cycle that began long before there were forests, long before there were animals, long before there were people, long before there was even a human mind capable of wondering about the stars. The world outside your window looks familiar, but it is ancient, much older than any city, older than any language, older than any civilization. The mountains beneath the clouds were not always there. The oceans have not always had their current shapes. The continents have moved. The climate has changed. Life itself has transformed the atmosphere, and the planet has passed through countless worlds that no human being ever saw. There was a time when Earth had no trees. There was a time when it had no animals. There was a time when its oceans were young. There was a time when the planet itself was still being formed. And if we could somehow travel backward through time, we would eventually watch our familiar world disappear. Cities would vanish first, then roads, then buildings, then agriculture, then human beings, then mammals, then dinosaurs, then forests, then complex life, and eventually, even the oceans as we know them would disappear. We could continue traveling backward, past the first life, past the first oceans, past the formation of the Earth itself, until there was no Earth at all. No moon, no sun, no solar system. Only a young cloud of gas and dust, drifting through space. But we are getting ahead of ourselves. For now, stay here, stay with the rain, listen to it for a moment, because before we travel through the deep history of the universe, we begin with the world beneath us, the world that became our home, the world that has carried life for billions of years, the world that, tonight, is quietly turning beneath the rain. Every mountain outside your window has a history. Every coastline has a history. Every grain of sand has a history. Even the air you are breathing has a history. And somewhere inside all of those histories, there is a story that began billions of years ago. A story of oceans, continents, volcanoes, ice, life, extinction, and change. The Earth has never been still. It has only appeared still to us. Over millions of years, the surface moves. Over billions of years, the planet transforms. Mountains rise. Rivers carve valleys, oceans open, oceans disappear, continents collide, continents separate, and through it all, life continues. Tonight, we are going to follow that story. Not quickly. There is no need to rush. We will move backward slowly, as if the rain outside were carrying us through time, from the world we know to the world that existed before us, from life to the first oceans, from Earth to the birth of the sun, from the sun to the ancient stars that existed before it. And, eventually, we will travel all the way back to the earliest moments of the universe. Then, we will turn around and slowly we will come home, back through the stars, back through the solar system, back to Earth, back to life, back to humanity, and finally, back to this rainy night. So for now, there is nothing you need to do. Let the rain remain in the background. Let the room remain quiet, and simply imagine that beneath the sound of every falling drop, an ancient story is waiting. A story older than humanity, older than civilization, older than the Earth itself. And tonight, we are going to listen to it. The rain is still falling. Outside the window, the world appears almost unchanged. The streets are wet. The buildings remain where they were. The trees move gently in the wind. And beneath all of it, the ground seems perfectly still. But if we could slow time down enough, we would see that the Earth is never truly still. The planet is constantly changing. Not quickly, not in ways that our eyes can easily notice, but over thousands, millions, and billions of years, the surface of Earth can become almost unrecognizable. A mountain can rise. A mountain can disappear. An ocean can open. An ocean can close. A continent can travel across an entire planet. And rocks quietly record much of that history. Every layer beneath our feet is a small piece of a much larger story. Some rocks were formed when molten material cooled. Others were created from sediments that accumulated slowly in ancient oceans. Some were transformed by immense pressure and heat deep beneath the surface. And some contain traces of life that existed hundreds of millions of years ago. The rocks do not speak, but they remember. They remember ancient environments, ancient climates, ancient oceans, and ancient worlds that no longer exist. Imagine looking at a mountain range. Tonight, perhaps the mountains are hidden beneath clouds. Rain moves across their slopes. Mist gathers around their peaks. From a human perspective, the mountains seem permanent. They seem as though they have always been there. But they have not. Every mountain has a beginning, and every mountain has a future. Some mountains are still rising today. Others are slowly being worn down. Rain falls across their surfaces. Snow melts. Rivers carry fragments of rock away. Wind removes tiny grains. Gravity pulls material toward lower ground. Very slowly, the mountain changes. A single rainfall seems meaningless. A single drop of water seems almost impossibly small. But repeat that process for millions of years, and the landscape begins to change. A valley becomes deeper. A cliff becomes smoother. A river moves farther into the rock. The earth is patient. It does not need to hurry. Time does the work. And perhaps this is one of the first things we need to understand about Earth's history. Human beings think in years. The planet thinks in millions of years. We notice a storm. The Earth experiences a cycle. We notice a mountain. The Earth experiences a geological process. We see a coastline. The planet sees something temporary. Even the continents, which feel impossibly large and permanent, are moving. The surface of Earth is divided into enormous tectonic plates. These plates move slowly across the planet, only a few centimeters each year. That is roughly the speed at which your fingernails grow. It seems insignificant, but over tens or hundreds of millions of years, those centimeters become thousands of kilometers. Continents can separate. They can collide. They can change the shape of entire oceans. Imagine watching the Earth from space, but with time moving 1,000,000 times faster. At first, nothing would seem to happen. Then, slowly, the continents would begin to move. Africa would shift. South America would drift. India would travel northward. Oceans would widen. Others would narrow. And eventually, continents could collide with one another. When they do, the Earth's crust can buckle. Rock can be pushed upward. Mountain ranges can form. The landscape changes, not because of a single dramatic event, but because of countless small movements, repeated over immense amounts of time. This is one of the strange things about geology. The greatest changes can come from processes that are almost invisible. A few centimeters, a little pressure, a little heat, a little erosion. Year after year, century after century, million after million, and eventually, the planet is different. The oceans have their own history. They were not always arranged as they are today. Ocean basins can open when tectonic plates move apart. New crust can form along underwater ridges. And as plates move, old crust can eventually be pushed back into the Earth's interior. The surface of the planet is constantly being recycled. Earth is not a finished object. It is a living geological system, not alive in the biological sense, but constantly changing, constantly reshaping itself. And the rocks beneath us are part of that process. Some rocks that are exposed at the surface today may once have been buried deep underground. Some may once have been part of an ancient seafloor. Some may have been melted and later cooled again. Some may have traveled through several different geological environments before finally reaching the surface. A single stone can have an extraordinarily long history. Imagine picking up a small rock. It looks ordinary, perhaps gray, perhaps brown, perhaps almost completely unremarkable. But that rock may be older than every human civilization, older than every city, older than agriculture, older than our species. Its atoms existed long before anyone was here to look at them, and the minerals inside it may have formed in an environment that no longer exists. The rock might have once been beneath an ancient ocean or inside a mountain that disappeared millions of years ago, or buried beneath layers of sediment until pressure transformed it. We often think of history as something written in books, but Earth's oldest history was written without words. It was written in stone. It was written in layers, in mineral structures, in chemical signatures, in tiny fossils, in patterns preserved inside ancient rock. And scientists have learned to read these clues. They can examine a layer of rock and reconstruct something about the environment in which it formed. Was the climate warm? Was the region underwater? Was there volcanic activity? Was oxygen present? Were living organisms nearby? Sometimes, a tiny fragment can reveal something enormous. A fossilized shell can tell us that an ancient sea once covered a region that is now far inland. A layer of volcanic ash can mark an eruption that happened millions of years ago. A change in the chemical composition of rocks can reveal major changes in Earth's atmosphere. The planet leaves clues everywhere. We only need to learn how to read them. And the deeper we look, the farther back in time we can travel. There are rocks on Earth that are more than 4 billion years old. Think about that. 4 billion years, a span of time so enormous that human intuition almost stops working. If the entire history of Earth were compressed into a single day, human civilization would appear only in the final moments, and your own lifetime would be less than a blink. The rain outside your window would fall for a few seconds and then disappear, but the Earth would continue. The continents would move, the mountains would rise, the oceans would change, life would evolve, extinctions would come, new species would appear, and the planet would continue writing its story. There were times when Earth looked nothing like it does tonight. There were periods when enormous portions of the planet were covered by ice. There were times when tropical forests stretched across regions that are now cold. There were times when sea levels were much higher. There were times when different continents were connected. And there were times when the atmosphere itself was radically different. The Earth we know is only one version of the planet, a temporary version, a moment in a much longer story. Tonight, as the rain falls, you are sitting on a planet that has already passed through countless worlds, worlds that existed and disappeared, without anyone being there to witness them. There was no human observer when the first mountains formed. No one was there when the first great oceans changed shape. No one watched the continents slowly separate. No one stood beneath the sky when the first forests covered the land. For most of Earth's history, the planet was completely alone. Life existed. The planet changed. But there was no species capable of looking backward and asking what had happened, until eventually we appeared. And now, for the first time, the planet has produced beings capable of reading its own history. We can examine rocks. We can study fossils. We can measure ancient atmospheric gases trapped in ice. We can analyze minerals. We can compare layers separated by millions of years. And from these fragments, we reconstruct a story. Not perfectly, not completely, but enough to glimpse worlds that vanished long before us. That is an extraordinary thought. The Earth has existed for billions of years, and now, a small species living on its surface is trying to remember. Perhaps that is why rocks can feel strangely beautiful. Not because they are visually impressive, but because they are patient. They have been here through things we can barely imagine. They existed before our languages, before our borders, before our cities, before our ancestors became human. And they will probably remain long after many things we consider permanent have disappeared. The rain continues, drop after drop. The water moves across the modern Earth. It touches roads, buildings, trees, mountains, and eventually it will return to rivers and oceans. But the water itself is ancient. The landscape is ancient. The planet beneath us is ancient. And if we continue traveling backward, we eventually reach a time when the Earth was not yet the world we know. A younger planet, a hotter planet, a more violent planet, a planet still becoming itself. The continents we recognize did not exist. The oceans were different. The atmosphere was different. And life, if it existed at all, was still unimaginably simple. We are approaching that world now. A world before forests, before animals, before humans. A world before the familiar Earth. And as the rain continues outside, we can slowly let the modern world fade away. The buildings disappear. The roads disappear. The lights disappear. The cities become silent. The continents begin to change. The oceans move. The atmosphere transforms. And the Earth becomes younger, younger, and younger, until eventually We arrive at the beginning of the planet itself. The rain is still falling, but now, let the world outside your window become older, much older. The streets begin to disappear. The buildings fade away. The lights of the city become distant memories. The familiar landscape slowly vanishes until there is only a young planet beneath a dark sky. Earth was not always blue. It was not always green. It was not always calm. More than 4 billion years ago, the planet was still becoming what it would eventually be. The surface was much hotter. Volcanic activity was widespread. Asteroids and other objects still collided with the young planet. The atmosphere was nothing like the air we breathe today. There were no forests, no animals, no birds moving through the sky, no oceans filled with familiar life, no human beings looking upward. There was only a young world, slowly cooling. The Earth had formed from material orbiting the young sun. Tiny particles had collided. They had gathered. They had grown. Larger bodies formed. Gravity pulled more material together, and eventually, a planet emerged. But becoming a planet was only the beginning. The early Earth was a difficult place. Heat remained trapped within the young world. Some of that heat came from the energy released during its formation. Some came from radioactive elements slowly decaying inside the planet. And some was generated by the enormous impacts that continued to strike its surface. The young Earth was not a peaceful blue sphere. It was a world of fire and rock. Volcanoes released gases. Molten material moved beneath the surface. The atmosphere was gradually developing. And above it all, the young sun was shining. The planet continued to cool. Slowly, very slowly, as temperatures decreased, something extraordinary began to happen. Water began to collect. Some water was likely released through volcanic activity as water vapor escaped from the interior of the planet. Some water may also have been delivered by water-rich asteroids and other bodies. The exact history is complex, but eventually, Earth possessed something that would become essential to everything that followed. Liquid water. Imagine the first great rains. Not a storm passing over a modern city, not a few hours of rain against a window, but rainfall occurring across a young planet over immense spans of time. Clouds forming, water falling, water collecting, rivers beginning to carve the young surface, basins filling, and gradually, the first oceans taking shape. The planet that had once been dominated by heat and rock was becoming a world of water. From space, Earth would eventually appear blue, but there was still no one there to see it. No eyes, no cameras, no spacecraft, no civilization, only the planet, and the chemistry unfolding across its surface. The oceans would become more than beautiful features of the planet. They would become enormous chemical environments. Water allowed molecules to move, to collide, to interact, to separate, to combine. And in certain environments, chemistry became increasingly complicated. Deep beneath the surface, heat from the planet continued to escape. Volcanic regions created intense chemical gradients. Minerals interacted with water. Energy moved through the environment. The young Earth was filled with countless different chemical settings. Shallow pools, volcanic landscapes, ocean floors, hydrothermal systems, coastal environments. Each offered different conditions, and somewhere, perhaps in one of these environments, chemistry began taking a remarkable direction toward life. We do not yet know exactly how life began. That remains one of the great unanswered questions in science. There are hypotheses. There are experiments. There are clues. But there is no complete story. We do not know the precise sequence of events that transformed non-living chemistry into the first living systems. And perhaps that uncertainty makes this part of Earth's history even more fascinating, because somewhere in that ancient world, something happened. Not necessarily in one dramatic instant, perhaps gradually, molecules became more organized. Chemical systems began interacting in ways that could sustain themselves. Some structures became capable of producing copies of themselves, and eventually, life appeared. The first life would not have looked anything like the creatures we know today. No eyes, no bones, no wings, no leaves, no heartbeat, only tiny organisms, living at a scale almost impossible to imagine. For a very long time, life remained simple. The planet was alive, but mostly invisible. Microorganisms occupied oceans and other environments. They reproduced, they changed, they competed, they adapted, and generation after generation, life continued. Imagine looking at Earth from space during this ancient period. You might see oceans, you might see clouds, perhaps volcanic regions, but you would not see forests. You would not see continents covered in green. You would not see animals. You would not see cities. You might not even recognize the planet as the home of life. And yet, life had already begun. Something extraordinarily important was happening beneath those ancient waters. Tiny organisms were changing the planet itself. One of the most important developments was photosynthesis. Some organisms evolved the ability to capture energy from sunlight. Among them were cyanobacteria, tiny organisms that would eventually have an enormous influence on Earth's atmosphere. Through oxygen-producing photosynthesis, they released oxygen as a byproduct. At first, that oxygen did not simply fill the atmosphere. It reacted with minerals and other substances. But over immense periods of time, oxygen began accumulating. The atmosphere slowly changed. The oceans changed. The chemistry of the planet changed. And life itself was changing the world in which it lived. This is one of the strangest ideas in Earth's history. The planet shaped life, but life also reshaped the planet. The atmosphere that surrounds us today is partly the result of billions of years of biological activity. The oxygen we breathe has a history. It is connected to organisms that existed long before animals, long before forests, long before humans. The air around you tonight is part of a story that began billions of years ago. And perhaps that is worth remembering while the rain continues outside. Every breath you take, depends on a planetary history far older than you, far older than your family, far older than your civilization, far older than humanity itself. The oxygen in your lungs exists because ancient organisms changed the chemistry of an entire planet, and the water in the rain outside is part of another ancient cycle. Water has been moving through Earth's atmosphere, oceans, and rocks for an immense span of time. The molecules themselves are ancient. They have passed through countless environments. They have been ocean water, atmospheric vapor, ice, river water, groundwater, and perhaps some of them have been part of living organisms. There is something almost poetic about that. The rain falling tonight may contain molecules that have been on Earth for billions of years. The planet recycles its materials again and again. Water moves, carbon moves, oxygen moves, minerals move. Life takes these materials, uses them, and eventually returns them to the environment. The Earth is constantly reusing the same basic ingredients. Nothing about the planet is truly isolated. Everything is connected. The atmosphere connects to the oceans. The oceans connect to the rocks. The rocks connect to the interior of the planet. Life connects to all of them. And slowly, the young Earth becomes more complex. The first oceans are no longer alone. The first life has begun changing its environment. The atmosphere is beginning to transform. The planet is moving toward another chapter, but that transformation would take an almost unimaginable amount of time. Millions of years, hundreds of millions, billions. There would be no sudden rush toward modern life, no straight line, no guarantee. Life would experiment. Species would appear. Most would disappear. Some would survive. New forms would emerge, and the planet would continue changing around them. There would be periods of stability. There would be periods of catastrophe. There would be ice ages, volcanic events, climate shifts, mass extinctions, and after each one, life would begin again. Slowly, patiently. The story of life is not a straight road. It is a vast, branching tree. Most branches eventually end. A few continue, and one tiny branch, many billions of years after the first life appeared, would eventually lead to us. But we are still far from humanity. Very far. There are still enormous chapters ahead. Complex cells, multicellular organisms, animals, plants, forests, dinosaurs, mammals, primates, humans. All of that remains in the future. For now, Earth is still a young world. A world of oceans, a world of microscopic life, a world slowly preparing for everything that will come later. And tonight, while the rain continues to fall, we can imagine standing beside one of those ancient oceans. There are no cities, no roads, no lights, no distant aircraft, only waves moving across a young planet, clouds passing overhead, volcanic landscapes in the distance, and beneath the water, tiny living organisms, almost invisible, almost insignificant. And yet, they are the beginning of a story that will eventually lead here to forests, 2 animals, 2 human beings, 2 cities, 2 you, sitting quietly, listening to the rain. But before any of that can happen, life has an almost unimaginable journey ahead, and the Earth has billions of years left to become the world we know. So, let the ancient ocean remain for a moment. Let the young Earth turn beneath its clouds. Let the rain outside your window connect this present night to a planet that once knew nothing of cities, nothing of humanity, and nothing of the distant stars. A planet still becoming itself. A planet still waiting for life to discover what it could become. And as we continue traveling through time, the first tiny organisms will slowly become more complex. The oceans will fill with new forms of life. The continents will change. And eventually, the quiet young Earth will begin to awaken. The rain is still falling, and somewhere beneath the sound of those drops, there is an ancient memory. Not a memory belonging to a person, not a memory written in a book, a memory written into the planet itself. Because long before humans walked across the Earth, long before forests covered the continents, long before animals moved through the oceans, life had already begun. We do not know exactly how. That part of the story remains hidden from us. We can study ancient rocks. We can recreate chemical environments. We can test possible reactions in laboratories. We can search for clues preserved in the oldest materials on Earth. But the exact moment when chemistry became biology remains one of the great mysteries of science. Perhaps there was no single moment. Perhaps there was no sudden beginning. Maybe the transition happened gradually, through countless chemical steps, over immense spans of time. The young Earth provided many different environments: oceans, shallow seas, volcanic regions, mineral-rich surfaces, hydrothermal systems, deep beneath the water. Everywhere, molecules were moving, colliding, breaking apart, combining again. Energy was flowing through the environment, and chemistry was becoming increasingly complicated. Some molecules could store information. Others could help chemical reactions occur. Some structures could form boundaries around themselves. And eventually, some systems may have gained an extraordinary ability, the ability to make imperfect copies of themselves. That changes everything. Once something can reproduce, even imperfectly, natural selection can begin to operate. Small differences can appear. Some versions may be more stable. Some may reproduce more effectively. Some may survive particular environments better than others. Over immense amounts of time, tiny differences can accumulate, and something that begins as simple chemistry can eventually become biology. But the first living organisms were nothing like the animals we know. They were microscopic, tiny cells, or systems resembling the earliest cells, living in environments that would be completely alien to us. There were no eyes watching them, no ears hearing them, no brains interpreting their surroundings. And yet, they were alive. They could grow. They could reproduce. They could interact with their environment. They could change, and they could evolve. For an almost unimaginable length of time, life remained simple. If we could travel back billions of years, and place ourselves above the ancient ocean, we might see nothing that resembles our modern world. No birds crossing the sky, no forests on distant shores, no animals swimming beneath the waves. Perhaps only a vast ocean under a strange atmosphere with microscopic life scattered throughout it. And yet, that invisible world was changing everything. Life was beginning to modify the planet. One of the most important transformations came from organisms that learned to use sunlight as an energy source. Photosynthesis allowed certain microorganisms to capture energy from the sun. Among them were cyanobacteria, tiny, simple, almost impossible to notice from a human perspective. But their impact would eventually become planetary. They released oxygen as a byproduct. At first, the oxygen reacted with substances in the oceans and rocks. Iron in particular could combine with oxygen, leaving behind minerals that would eventually form distinctive layers in ancient rocks. But as these chemical sinks became increasingly saturated, oxygen began to accumulate in the atmosphere. The planet was changing. The air itself was changing. And that change would transform the future of life. For organisms that evolved without oxygen, the new atmosphere could be dangerous. For others, oxygen would become an extraordinary source of energy. A new world was beginning, one in which life could extract far more energy from food. That additional energy would eventually make more complex forms of life possible. But this transformation did not happen quickly. The rise of oxygen unfolded over enormous spans of time. The atmosphere did not suddenly become like the one we breathe today. Instead, oxygen slowly accumulated. The chemistry of the oceans changed. Minerals reacted. The atmosphere evolved. And life continued adapting. This is one of the remarkable patterns in Earth's history. Life changes the environment, and then the changed environment influences life. The two become connected. The planet shapes its inhabitants. Its inhabitants reshape the planet. A relationship begins that will continue for billions of years. Tonight, as you listen to the rain, you are breathing the result of this ancient relationship. The oxygen entering your lungs has a history. It is part of a planetary story that began long before animals existed, long before trees, long before dinosaurs, long before mammals, long before humans. Every breath connects you to organisms that lived billions of years ago. Tiny organisms that had no idea they were changing the future. They were simply living, consuming energy, reproducing, growing, and releasing oxygen. But eventually, the chemistry of Earth became favorable for something else, more complex cells. For a very long time, life consisted mostly of relatively simple cells. Then, more than 1 billion years ago, something remarkable happened. Cells with internal structures became widespread. The evolution of complex cells involved extraordinary biological innovations. One of the most important was the development of organelles, such as mitochondria, structures that help cells extract energy efficiently. The leading scientific explanation is that mitochondria originated from ancient bacteria that entered into a long-term partnership with another cell. Instead of being destroyed, the bacteria became part of the cell. Over generations, the relationship became permanent, a partnership that would eventually become one of the foundations of complex life. Again, the change was not sudden. Evolution rarely works like a switch being turned on. It works through small changes, over immense amounts of time. A little difference here, a small advantage there, a mutation, a new relationship, a new environment, a survival opportunity, and eventually, the descendants can become something entirely different from their ancestors. This is difficult to appreciate because human lives are so short. We see change in years. Evolution often works over millions of generations. Imagine watching a single tree grow. You would see branches slowly extending, leaves appearing, perhaps a flower opening. But you would not see the tree becoming an entirely different kind of organism. Now imagine watching a forest for 100 million years. The concept changes completely. Species appear, species disappear, entire ecosystems transform. The world itself changes, and life changes with it. Eventually, some complex cells began living together. Multicellular organisms became possible. At first, they were simple, perhaps little more than groups of cells cooperating. But cooperation opened another door. Different cells could begin performing different functions. Some could specialize in movement, others in feeding, others in reproduction, others in protection. The organism became more than a collection of identical cells. It became a system, a community of cells working together. This was another enormous step. Because once cells could cooperate, life could become larger, more complex, more specialized, and eventually far more diverse. But there was still a long way to go. For billions of years, life had been experimenting almost entirely at microscopic scales. Then, the world began to change. Oxygen levels continued to evolve. Climates shifted, oceans changed, continents moved, and eventually, the conditions became suitable for a remarkable expansion of complex life. The oceans began to fill with new forms. Bodies became larger. Structures became more sophisticated. Movement became more important. Predation appeared in increasingly complex forms. And life began to interact with its environment in new ways. The planet was entering another chapter. The long, quiet age of microscopic life was beginning to give way to a more visible world. A world filled with organisms that could move, sense, feed, compete, and eventually see. But before that world arrives, take a moment to imagine the ancient Earth again. There are no cities, no roads, no aircraft, no artificial lights, no sound of human voices, only an ancient ocean beneath an ancient sky. The water moves slowly, clouds pass overhead, tiny organisms drift beneath the surface, and inside those tiny organisms, millions of years of evolution are waiting to unfold. The future is already hidden there. Forests are hidden there. Animals are hidden there. Dinosaurs are hidden there. Birds are hidden there. Mammals are hidden there. Humans are hidden there. Not physically, but as possibilities. The first life could never have known what it would eventually become. A microscopic organism had no concept of forests, no concept of intelligence, no concept of civilization. And yet, after billions of years, its descendants would eventually build cities, write books, look at the stars, and wonder how life began. Perhaps that is one of the most beautiful things about evolution. The beginning does not know the ending. A small change can become the beginning of something enormous. A simple organism can become part of a lineage that eventually transforms an entire planet. And the planet itself continues changing alongside it. Tonight, the rain is falling on a world transformed by life. Trees release oxygen. Microorganisms move through the soil. Plants absorb carbon dioxide. Animals breathe oxygen. Oceans contain enormous ecosystems. And beneath all of this, ancient biological cycles continue. The Earth is no longer the young world we imagined earlier. It has become a living planet. But the story is only beginning. Because now, life is preparing to leave the microscopic world behind. The oceans will soon become filled with creatures unlike anything that came before. Bodies will become more complex. Eyes will appear. Movement will accelerate. Predators will emerge. And eventually, life will begin reaching toward the land. The quiet ocean of the ancient Earth will become the stage for one of the greatest transformations in the history of the planet. The long age of visible life is about to begin. And while the rain continues outside your window, we can let the story move forward, slowly, patiently, one ancient moment at a time. The rain continues outside, and far beneath the sound of it, the Earth is becoming increasingly alive. For billions of years, life had remained mostly hidden. Tiny cells drifting through ancient oceans. Simple organisms living in darkness. Microscopic communities changing the chemistry of the planet. But eventually, the story began to change. Life became larger, more complex, more visible. The oceans began to fill with unfamiliar forms. Some moved. Some filtered food from the water. Some crawled across the sea floor. Some developed protective shells. And some began hunting. For the first time, the ancient oceans were becoming crowded with life. It is difficult to imagine what those seas looked like. There were no familiar fish, no whales, no coral reefs as we know them. No forests reaching toward the sky. Instead, there were strange organisms, unlike almost anything alive today. Some had soft bodies, some possessed shells. Others had structures that would eventually become distant ancestors of much more familiar animals. Life was experimenting, and evolution was producing possibilities. Some survived, others disappeared. The history of life is filled with both. Every species that exists today is part of a lineage that survived countless challenges. And for every lineage that survived, there were countless others that ended. Extinction is not an exception in the history of life. It is one of its defining features. Most species that have ever lived are gone. They disappeared millions of years ago, or hundreds of millions. Some existed for only a brief period. Others survived for enormous spans of time. But eventually, their story ended. The Earth continued, and life continued with it. One of the most remarkable periods in this story occurred around 540 million years ago. The fossil record begins showing a remarkable increase in the diversity and complexity of animal life. This period is often called the Cambrian explosion. It was not an instantaneous explosion in the ordinary sense. It unfolded over millions of years, but compared with the immense stretches of simpler life that came before, the transformation was dramatic. Animals with recognizable body plans appeared. Movement became more important. Predation became more sophisticated. Eyes evolved. Hard structures became common. The oceans became increasingly dynamic. Imagine floating above one of those ancient seas. The water below you would contain creatures unlike anything you have ever seen. Some would crawl along the seafloor. Others would swim. Some would hunt. Others would hide. Every organism would be part of a new ecological experiment. And the experiment was only beginning. Life would continue evolving. Fish would eventually appear. Some would develop jaws. Others would develop stronger bodies and more efficient ways of moving through water. The oceans became increasingly complex ecosystems. And then, something extraordinary happened. Life began moving onto land. The transition was gradual. There was no single afternoon when the first animal simply stepped onto a beach and decided to stay. Instead, organisms gradually adapted to shallow water, then to environments close to shore, then to temporary exposure to air. Over generations, some developed characteristics that made life outside water increasingly possible. Plants had already begun establishing themselves on land. Mosses and other early plants spread across moist environments. Later, vascular plants developed systems capable of transporting water and nutrients through their tissues. Roots became more sophisticated. Stems became stronger. Leaves became more effective. And eventually, the land began turning green. Imagine traveling back hundreds of millions of years and looking across a landscape that is completely unfamiliar. No modern cities, no roads, no farmland, no houses. Instead, vast stretches of vegetation, ancient plants, huge forests, wet landscapes, swamps, and an atmosphere unlike the one outside your window tonight. Some of these ancient forests would eventually become the source material for enormous deposits of coal. Plants grew. They died. They accumulated in waterlogged environments. They were buried. Pressure and heat transformed their remains over geological time, and millions of years later, humans would extract some of that ancient stored carbon and burn it for energy. In a strange way, some of the energy that powered industrial civilization came from sunlight captured by plants hundreds of millions of years ago. The Earth stores its history in many forms, sometimes in rocks, sometimes in fossils, sometimes in the atmosphere, and sometimes in the energy hidden inside ancient biological remains. But life on land was becoming more complex. Insects appeared, arthropods diversified, early amphibians moved through wetlands. Eventually, reptiles became increasingly adapted to life away from water. The continents changed, the climate changed, and ecosystems expanded. Then came the great age of reptiles, dinosaurs. For more than 160 million years, different groups of dinosaurs dominated many terrestrial ecosystems. They were extraordinarily diverse. Some were enormous, others were small. Some walked on 2 legs, others on 4. Some were predators, others herbivores. Some had feathers, and among their distant descendants, birds would eventually emerge. When we imagine dinosaurs, we often imagine a single world. But there was never just one dinosaur world. There were countless ecosystems, different continents, different climates, different species, different periods. The Earth was changing continuously. The dinosaurs changed with it. New species appeared, others disappeared, and the landscapes themselves transformed. Forests moved, oceans shifted, mountains rose, volcanoes erupted. The climate changed. The continents continued their slow movement, and through all of this, dinosaurs remained a major part of life on land. But the story of life is never permanent. Eventually, one of the most famous catastrophes in Earth's history occurred. About 66 million years ago, a large asteroid struck what is now the Yucatan Peninsula. The impact released enormous amounts of energy. Dust and other material entered the atmosphere. Wildfires spread across vast areas. Climate conditions changed. Food webs collapsed, and many species disappeared. The non-avian dinosaurs were among the victims. But not all life disappeared. Birds survived. Mammals survived. Reptiles survived. Insects survived. Plants survived. Marine organisms survived. The planet remained alive. And after the catastrophe, something remarkable happened. Life recovered. Not instantly, not easily, but gradually. Surviving organisms occupied environments that had been left open. New species evolved. New ecosystems formed. And mammals, which had existed for a very long time already, began to diversify in extraordinary ways. Some became larger. Some returned to the oceans. Some developed specialized teeth. Others adapted to forests. Some became capable climbers. Some developed complex social behaviors. And, eventually, among the many branches of mammalian evolution, primates appeared. But even then, human beings were still far in the future. The Earth had already existed for more than 4 billion years. Life had already survived enormous changes. Entire worlds had appeared and disappeared, and still, our story had not begun. That perspective can feel almost overwhelming. We often think of human history as something enormous. Thousands of years of civilization, empires, wars, discoveries, languages, cities, technology. But compared with the history of life, human civilization is almost impossibly recent. Imagine compressing the entire history of Earth into one calendar year. January would represent the formation of the planet. Life would appear relatively early. Complex organisms would arrive much later. Dinosaurs would dominate near the end of the year. The asteroid impact would occur very late in December. Humans would appear only in the final moments. And recorded history would occupy a tiny fraction of the final fraction of a second. The rain outside your window might last longer than the entire period of written human history on that scale. And yet, here we are, listening to it, thinking about it, trying to understand the world that came before us. There is something humbling about that. The Earth did not exist for us. It existed for billions of years before our arrival. Life did not evolve with humanity as its destination. Evolution has no predetermined endpoint. It simply responds to changing environments. Lineages branch. Some survive. Some disappear. And occasionally, one of those branches leads somewhere extraordinary. But even after mammals diversified, the human story was still only beginning. The first primates would appear. Later, apes. Later still, early hominins. Then members of the genus Homo. And eventually, our own species. But before we reach them, take a moment to imagine the Earth from above. A world covered in oceans, continents slowly moving, forests spreading across enormous regions, animals moving through ancient landscapes, dinosaurs long gone, mammals diversifying, the planet turning beneath the sun, clouds moving across the atmosphere, seasons changing, rivers flowing, rain falling. Much like tonight, the sound of rain is not new. Water has been falling from Earth's atmosphere for an almost unimaginable length of time. It fell before humans, before mammals, before dinosaurs, before forests, before animals walked on land. Rain has been part of the planet's story for billions of years. Tonight, we simply happen to be here to hear it. And as the rain continues, the story moves closer to us. The ancient forests begin to disappear behind us. The great reptiles become distant. The mammals come forward. The primates begin to appear. The world starts becoming more familiar. But it is still not our world. Not yet. There are still millions of years to go. Still countless generations. Still migrations. Still discoveries. Still fires lit beneath unfamiliar skies. Still tools shaped by human hands. Still the first words. Still the first communities. Still the first cities, all of them waiting in the future. For now, the Earth is turning beneath the rain. Life continues. The oceans move. The forests breathe. The continents drift. And somewhere within this enormous living history, one small branch is beginning to take a direction that will eventually lead to us. The world that became our home is getting closer, slowly, quietly, one generation at a time. The rain is still falling, and the Earth is becoming more familiar. Not yet the Earth we know, Not yet the world of cities and roads and lights, but the distant beginnings of it are starting to appear. The great age of dinosaurs has ended. Mammals are spreading into new environments. Forests cover large parts of the continents. The oceans remain full of life, and somewhere among the branches of mammalian evolution, a new story is beginning. The story of primates. At first, there is nothing particularly remarkable about them. Small mammals moving through ancient forests, climbing, searching for food, avoiding predators, living in environments where survival depends on constant adaptation. Millions of years pass. Species change. Branches split. Some lineages disappear. Others continue. And, among them, apes eventually appear. The world around them keeps changing. Forests expand and contract. Climate shifts. Grasslands become more widespread in some regions. The landscapes of Africa transform, and some ancient primates begin spending more time moving across the ground. Eventually, some develop characteristics that make walking upright increasingly useful. Bipedalism becomes one of the defining features of the human lineage, but it does not happen overnight. There is no single moment when an ape suddenly becomes human. Instead, there are countless generations, small anatomical changes, different ways of moving, different environments, different pressures, and over immense spans of time, a lineage slowly becomes something new. Our earliest ancestors were not modern humans. They did not look like us. They did not speak our languages. They did not build cities. They did not understand the stars. They simply lived. They walked. They searched for food. They cared for their young. They faced predators. They adapted. And eventually, some began using objects as tools. A stone could become useful. A sharp edge could help cut. A heavy object could be used to break something open. The difference between a random stone and a tool is not always the shape of the object. It is the intention behind it. A mind looking at an ordinary piece of stone and imagining what it could become. That ability would become increasingly important. Tools improved. Hands became more capable. Brains became larger in some branches of the human lineage. Social cooperation became increasingly important. Communication became more sophisticated. And eventually, fire entered the story. We do not know exactly when humans first began controlling fire. The relationship between early humans and fire developed over a very long period. But once fire became a reliable part of human life, the world changed. Fire provided warmth. It provided light. It helped protect against some predators. And it allowed food to be cooked. Cooking changed the way humans interacted with food. It made certain foods easier to digest. It changed the amount of energy that could be extracted from meals. And fire also created something else, a place to gather. Imagine an ancient group sitting around a fire at night. There are no electric lights, no buildings, no streets, only darkness beyond the small circle of warmth. Someone tends the flames. Someone watches the surrounding landscape. Children remain close to the adults, and above them, the night sky is enormous. much larger than the night sky most people see today. There are no city lights washing out the stars. The Milky Way stretches overhead. The stars appear impossibly numerous. And perhaps someone looks upward. Perhaps they wonder. Perhaps they simply watch. But the connection between humans and the night sky is already beginning. The same stars that we can see today were already shining above our ancestors. Different people, different world, same universe. As generations passed, humans spread into new regions. They moved across Africa. Eventually, some populations migrated beyond it, across deserts, across grasslands, into colder regions, toward coastlines, across enormous distances. They adapted to different climates, different foods, different landscapes, different dangers. Humanity became a traveling species, and everywhere people went, they carried something with them: memory, knowledge, stories, tools, fire, language, culture. Each generation inherited information from the previous one and added something new. This ability to accumulate knowledge became one of the most powerful forces in human history. An animal can learn, but humans became extraordinarily good at preserving what had been learned and passing it forward. A tool could be improved, a hunting technique could be remembered, a useful plant could be identified, a dangerous place could be avoided. A story could explain where to find water. A younger generation could inherit knowledge without having to rediscover everything from the beginning. Culture began accelerating evolution in a different way. Human beings were no longer adapting only through biology. They were adapting through knowledge. Eventually, people began staying in particular places for longer periods. They learned to manipulate plants. They domesticated animals. Agriculture emerged independently in different regions. And something enormous happened. Human populations began growing. Permanent settlements became possible. Villages became larger. Some eventually became towns, and eventually, cities appeared. The first cities were nothing like the enormous urban landscapes of today. They were small by modern standards, but the idea itself was revolutionary. Thousands of people could live together. Food could be stored. Work could be divided. Trade could expand. Specialized skills could develop. People could become builders, potters, metal workers, farmers, traders, priests, administrators, artists. The human world became increasingly complex. Writing eventually appeared in several regions, and once information could be recorded outside the human mind, history changed again. Knowledge no longer needed to exist only in memory. It could be written, copied, stored, transported. Centuries later, someone could read the words of someone who had lived long before them. Humanity had developed a kind of memory that could survive individual lives. Civilizations rose. Civilizations fell. Kingdoms expanded. Borders changed. Languages evolved. New technologies appeared. Ships crossed oceans. People mapped continents. science began describing the natural world in increasingly precise ways. And eventually, human beings learned that the Earth was not the center of everything. The sun was a star. The Earth was a planet. The moon was another world. The stars were distant suns. And the universe was far larger than anyone had imagined. But even after all those discoveries, humanity remained a very recent arrival. The Earth was already more than 4 billion years old. Life had already existed for billions of years. Dinosaurs had already lived and disappeared. Mammals had already diversified. The continents had already moved enormous distances. And then, in the final moments of geological history, we appeared. That perspective can be difficult to feel. So imagine the history of Earth as a single, long road. At the beginning, there is the formation of the planet. Then comes the first life. Then billions of years of evolution. Forests, oceans, dinosaurs, mammals, primates, and finally, human beings. Our entire civilization is almost at the very end of the road. The cities that seem so permanent are extremely recent. The countries that seem so old are recent. The languages we speak, recent. The technologies we use, almost unimaginably recent. And this rainy night, this tiny moment, is even smaller. You might think that makes human life insignificant, but perhaps it does something else. Perhaps it makes it precious, because out of billions of years of geological and biological history, there is now a species capable of looking backward, a species capable of asking, where did we come from? Why are we here? How did this world become our home? And perhaps most importantly, what came before us? Tonight, we are following those questions backward. We have already traveled through human history. We have watched civilizations appear. We have watched our ancestors emerge. We have watched mammals diversify. We have watched dinosaurs disappear. We have watched life leave the oceans. We have watched the first complex organisms appear. And now, we can go farther, much farther. Because before Earth became our home, it had to exist. And before Earth existed, the sun had to exist. And before the sun, there was only the raw material from which our solar system would eventually form: gas, dust, gravity, and the remains of ancient stars. The elements in your body did not all originate here. The carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood, all have stories that reach beyond Earth. Some of those elements were forged inside stars that lived and died long before the sun was born. So our story does not end with humanity. It does not even end with Earth. We have to leave our planet behind and travel into the darkness before the solar system existed. Imagine the rain outside becoming distant. The sound remains, but the modern Earth begins to fade. The cities disappear. The roads disappear. The farms disappear. The forests disappear. The animals disappear. Humanity disappears. And then, Earth itself disappears. There is no blue planet anymore. No moon. No oceans. No familiar sky. Only a cloud of gas and dust, slowly gathering beneath the force of gravity. The sun has not yet been born. The planets have not yet formed, but the ingredients are already there, waiting. And as we continue backward, we are about to reach the moment when our solar system began to take shape. The rain is still falling, but now we are leaving Earth behind. Slowly, quietly, the cities disappear, the forests disappear, the oceans disappear, the mountains disappear. Even the planet itself begins to fade from our story. There was a time when Earth did not exist. No blue world, no continents, no oceans, no moon hanging in the night sky, no atmosphere, no life, and yet the ingredients that would eventually become Earth were already somewhere in space. Dust, gas, ice, rock, tiny particles drifting through an enormous cloud. The story of our planet begins long before the planet itself existed. It begins with a star, our sun. But even the sun had a beginning. About 4.6 billion years ago, a region of gas and dust in the Milky Way began collapsing under its own gravity. We do not know every detail of what triggered the collapse. Perhaps a shock wave from a nearby stellar explosion disturbed the cloud. Perhaps the cloud became unstable for other reasons. Whatever the precise cause, gravity began to take control. The cloud slowly contracted. As it collapsed, it began rotating more rapidly. The material flattened into a broad disk. At the center, matter became increasingly concentrated. Density increased, temperature increased, and eventually, the young sun began to take shape. Imagine that moment from far away. There is no bright yellow sun yet, no familiar star, only a dark region of space, filled with gas and dust. But gravity is quietly gathering everything together. Particle by particle, collision by collision, the central region becomes hotter, denser, more massive, and eventually, the conditions become extreme enough for nuclear fusion to begin. Hydrogen nuclei begin combining into helium. Energy is released. The young sun becomes a true star. For the first time, our solar system has a central light. But the story does not end there. Around the young sun, the disk of material continues to rotate. Tiny grains of dust collide. Some stick together, others break apart. But gradually, larger structures begin forming. Millimeter-sized grains, pebbles, rocks, larger bodies, and eventually, planetesimals. These objects continue colliding. Gravity becomes increasingly important. The larger they become, the more effectively they attract surrounding material. A small object becomes larger. A larger object attracts even more material. The process continues. Over millions of years, the solar system begins to take shape. The planets are not created instantly. They grow, they collide, they merge. They are sometimes destroyed. Some objects are thrown out of the system. Others fall toward the young sun. And some remain, becoming the worlds that will eventually orbit the star, closer to the sun, Temperatures are high. Only certain materials can remain solid. Farther away, colder conditions allow different materials to survive. This helps explain why the planets of our solar system developed such different compositions. The inner planets became mostly rocky worlds. Mercury, Venus, Earth, Mars. Farther out, the giant planets formed in colder regions. Jupiter, Saturn, Uranus, Neptune. Each world became different. Each followed its own history. And among all of them, one small rocky planet would eventually become our home, Earth. But before Earth became blue, it was something very different. A growing world surrounded by debris. Its surface was being shaped by enormous impacts. Asteroids and other planetary bodies collided with it. The energy released by these impacts was enormous. The young planet became hot, very hot. Parts of its interior were molten. Dense materials sank toward the center. Lighter materials remained closer to the surface. The Earth began differentiating into layers, a core, a mantle, and eventually a crust. But even then, Earth was not finished. The young planet continued being bombarded. One of the most important impacts in its early history may have involved a Mars-sized body. The collision was enormous. Material was thrown into orbit around the young Earth. Over time, that material gathered together, and from it, the Moon formed. The Moon that appears so peaceful on a clear night was born from violence. Today, it moves silently around Earth. Its gravity influences the tides. Its presence contributes to the long-term stability of Earth's rotation. But billions of years ago, it was part of a chaotic collision. The early Earth continued cooling. The surface gradually became more solid. Volcanoes released gases. Water vapor entered the atmosphere. And eventually, liquid water could persist on the surface. The planet was beginning to resemble the world we know, but there was still no life. No forests, no animals, no humans. Only oceans, rocks, volcanoes, and an atmosphere unlike today's. The continents we know had not yet taken their modern forms. The planet was still changing, and somewhere within its oceans, the chemistry that would eventually produce life was beginning. But before we move forward, look back at the journey. A few moments ago, we were sitting on a rainy Earth. We watched humanity. We watched animals. We watched dinosaurs. We watched forests. We watched the first life. And then we watched Earth itself disappear. Now we are standing in the young solar system. The sun has just been born. The planets are still forming. Earth is still a young world, and everything we know is still waiting in the future. The rain outside your window does not exist yet. The oceans do not exist in their modern form. The water cycle has not begun. The oxygen in your lungs does not exist. The trees do not exist. The animals do not exist. You do not exist. Humanity does not exist. But the atoms that will eventually become part of all those things are already here. That is one of the strange truths about cosmic history. The ingredients of the future can exist long before the future itself. The carbon that will one day become part of a human body can exist inside an ancient cloud of gas. The oxygen that will one day fill human lungs can exist inside minerals. The iron that will one day flow through human blood can already be present in the material from which planets are forming. Nothing is appearing from nowhere. Matter is being rearranged. Stars make some elements. Stars release them. Clouds gather them. Planets form from them. Life uses them. And eventually, conscious beings look back and wonder where everything came from. The story is becoming more connected. The Earth came from the solar system. The solar system came from a cloud of material. That material came from earlier generations of stars. And those stars came from an even older universe. So if we want to understand where Earth came from, we cannot stop at the birth of the sun. We have to go farther, much farther, because the sun was not the first star. The Milky Way existed before it, and the Milky Way itself had an even longer history. The material that formed our solar system had been through other stars before reaching us. Some atoms were born in stellar interiors. Some were forged in violent explosions. Some were created in other extreme cosmic environments. Then they drifted through space, waiting for gravity to gather them again, waiting for a new star, waiting for planets, waiting for oceans, waiting for life, waiting for us. Imagine the young solar system once more. The sun shines at its center. Around it, a disk of material slowly becomes worlds. One of them is Earth. At first, it is little more than a hot, young planet. But time is about to transform it. Its surface will cool. Its atmosphere will change. Its oceans will form. Life will appear. And billions of years later, someone will sit beside a window on a rainy night and wonder how all of this began. The rain continues, but the sound now feels different, because the water falling outside belongs to a story that began long before there were oceans, long before there were clouds, long before there was even a planet. And if we travel farther backward, we will discover that the sun itself was built from material created by stars that lived before it, stars that have already disappeared, stars whose light may no longer reach us, stars that existed before Earth, before the moon, before the sun. So now, we leave our young solar system behind. The planets fade, the sun fades, the disk of dust disappears, and we travel deeper into the Milky Way, toward the ancient stars, whose deaths helped make our world possible. The story of Earth is about to become a story about stars. The rain continues, but we are now so far from the rainy Earth that even the Earth itself has become a distant memory. The sun is gone. The planets are gone. The young solar system has disappeared, and we are looking at something much older. Stars. Ancient stars that existed long before our sun. long before Earth, long before humanity. The material that eventually became our solar system did not begin with the sun. It had already traveled through the universe for billions of years. It had been part of other stars, other clouds, other explosions, other worlds. To understand where the Earth came from, we have to understand where its elements came from. Because the universe did not begin with all the elements we see around us today. In the earliest universe, matter was much simpler. Hydrogen dominated. There was also helium and tiny amounts of lithium, but there was no earth, no iron, no silicon, no carbon-rich forests, no oxygen-filled atmosphere, no calcium in bones, no complex chemistry like the chemistry surrounding us tonight. The heavier elements had to come later, and stars would become some of the great factories that produced them. Imagine an ancient cloud of hydrogen floating through a young galaxy. Gravity slowly gathers the gas. The cloud becomes denser. Eventually, a star is born. Inside its core, the pressure is enormous. The temperature is immense. Hydrogen nuclei collide, and under the right conditions, they fuse together. Hydrogen becomes helium. Energy is released. The star shines. For millions or billions of years, the star remains in balance. Gravity pulls inward. Energy generated in the core pushes outward. The star lives between these two forces, but inside, something extraordinary is happening. The star is changing its own material. Hydrogen is becoming helium. And when the hydrogen in the core becomes depleted, the story changes again. Depending on the star's mass, new nuclear reactions can begin. Helium can be fused into heavier elements. Carbon can be produced. Oxygen can be produced. In massive stars, the process can continue even farther. Elements become progressively heavier. Carbon, oxygen, neon, magnesium, silicon, and eventually iron. Iron is different. Fusion involving iron does not provide the same energy advantage as the earlier fusion reactions. The star approaches a limit. Its core can no longer continue producing energy through fusion in the same way. And when a massive star reaches this stage, its final moments can be extraordinary. The core collapses. In a fraction of a second, enormous amounts of matter are compressed. The star's outer layers can be violently expelled. A supernova. For a brief period, a single exploding star can shine with extraordinary brightness. But the light is only part of the story. The explosion also spreads material into surrounding space. Elements created inside the star and elements produced or transformed during the violent event are thrown outward. The star dies, but its material becomes part of the future. This is one of the most beautiful ideas in astronomy. A star can die and become the raw material for another generation. Its atoms do not simply disappear. They travel. They mix with interstellar gas. They become part of new clouds, new stars, new planets, perhaps new life. The carbon in your body has a story that reaches beyond Earth. The oxygen you breathe has a story that reaches beyond Earth. The iron in your blood has a story that reaches beyond Earth. The calcium in your bones has a story that reaches beyond Earth. The silicon in rocks has a story that reaches beyond Earth. The universe is constantly recycling matter. Stars are born from the remains of earlier stars. Planets form from material released by ancient stellar generations. And eventually, life can use those elements. This means that when we look at the night sky, we are not simply looking at distant lights. We are looking at part of the history that made us possible. The stars existed before us, but some of them also helped create the ingredients from which we are made. Our sun was not one of the universe's first stars. It formed from material that had already been enriched by previous generations. By the time the sun was born, the galaxy had already experienced billions of years of stellar history. Stars had lived. Stars had died. Their material had spread through space. Clouds had formed. New stars had appeared. And the cycle continued. Our solar system arrived relatively late. The universe was already ancient. The Milky Way was already filled with generations of stars. And somewhere within that vast galaxy, the material that would eventually become the Earth was drifting through space. Imagine it. Before there was a planet, there was dust. Before there was an ocean, there were atoms. Before there were clouds above Earth, there were clouds between stars. Before there was life, there was chemistry. And before there was a human being looking toward the night sky, there were stars creating the ingredients that would eventually become a human body. The chain stretches backward, far beyond our intuition. But stars were not the only places where heavy elements could form. Some of the universe's heaviest elements are associated with extreme events. Neutron stars are among the most remarkable objects known. They are the collapsed cores left behind by certain massive stars. Imagine compressing more mass than the sun into a sphere only a few tens of kilometers across. Matter becomes extraordinarily dense. Gravity becomes immense. The physics is extreme. And when two neutron stars collide, the event can produce enormous amounts of energy and create or disperse some very heavy elements. Gold, platinum, and other elements that are rare on Earth may have cosmic origins connected to events like these. So even something as familiar as gold, a small piece of metal held in a human hand, can have a history involving the most violent environments in the universe. It is difficult to imagine. A piece of jewelry resting quietly in a drawer may contain atoms that were forged in an ancient cosmic catastrophe, long before the sun existed. The universe does not separate the beautiful from the violent. The same cosmic processes that destroy stars can create the material from which planets and life eventually emerge. Creation and destruction are often part of the same process. A star dies, its material spreads outward. That material becomes part of a cloud. The cloud forms another star. Planets form around it. Those planets change. One may develop oceans. One may develop life. And eventually, one of those worlds may produce a creature. capable of wondering where its atoms came from. That is where we are now. Traveling backward, we have gone from a rainy night to Earth, from Earth to life, from life to the formation of the planet, from the planet to the birth of the sun, and now, beyond the sun, to ancient stars. But even these stars were not the beginning. They were already part of an older universe. The Milky Way itself had a history. The first stars formed when the universe was much younger. The first galaxies began gathering. Gravity assembled enormous structures from matter that had once been spread almost uniformly across space. The universe became increasingly complex, and eventually, after billions of years, one of those galaxies would become home to our sun. The stars we see today are not all the same age. Some are relatively young, others are extremely old. Some were born long after the universe began. Others formed from some of the earliest generations of stellar material. When we look at a star, we are seeing light from a particular moment in its history. Because light takes time to travel, the sky is also a kind of archive. A distant star is never seen exactly as it is right now. We see it as it was when its light began its journey toward us. For nearby stars, the difference is relatively small. For distant galaxies, the difference can be enormous. We can look across billions of light years and see the universe as it appeared billions of years ago. In that sense, astronomy allows us to travel through time. We do not need a machine. We simply need light. Every photon arriving from a distant object carries information about the past. The universe is constantly sending us its history. And tonight, we are following that history backward. The stars become older, the galaxies become younger, the structures become less developed. Eventually, we reach a universe before our Milky Way existed in anything like its current form. A universe before the sun, before Earth, before the first complex life, before the first stars like the ones we know. And eventually, we reach a universe before stars existed at all. The night sky disappears. There are no familiar constellations, no bright stars, no planets, no galaxies resembling the Milky Way, only an enormous young universe, filled with simple matter. But before we reach that beginning, pause for a moment. Imagine the rain outside again. Each drop falls onto a modern Earth, perhaps onto a road, perhaps onto a tree, perhaps against the window beside you, and somewhere inside that water, inside the air around you, inside the minerals beneath the ground, are atoms with histories stretching back billions of years. Some were once inside stars. Some were scattered through stellar explosions. Some traveled between stars. Some became part of the cloud that formed our sun. Some became part of Earth. Some became part of life. And eventually, some became part of you. You are not separate from the cosmic story. You are one of its later chapters. A very recent chapter. A very small chapter, but a conscious one. A chapter capable of looking backward and asking where the story began. And now, We are almost there. The ancient stars fade. The galaxies become younger. The universe becomes simpler. The first elements dominate. The first atoms appear. And eventually, even those atoms disappear from the story. We are approaching the earliest chapter we can meaningfully describe. The birth of the universe itself. The reign continues. But for a moment, let it become distant. Because we are about to travel farther back than any star has ever existed. Farther back than any planet. Farther back than Earth. Farther back than the Sun. We are approaching the beginning of cosmic time. The rain is still falling, but now there is no Earth, no Sun, no stars, no galaxies. We have traveled so far backward through time that even the oldest stars have disappeared. The universe is young, almost unimaginably young, and everything we know is still waiting to happen. There is no Milky Way, no distant galaxy shining across the darkness, no familiar constellations, no planets, no oceans, no life. The universe we know today, with all its stars and galaxies, has not yet taken shape. About 13.8 billion years ago, the universe was in an extremely hot, dense state. Space itself was expanding, and as the universe expanded, it cooled. This is the beginning of the story we can trace with modern cosmology. Not an explosion happening inside pre-existing empty space, but an expansion of space itself. There was no center that everything was flying away from. Every region of the early universe was part of the expansion. Imagine dots drawn across the surface of a balloon. As the balloon expands, every dot moves away from every other dot. There is no single dot that represents the center of the expansion. The early universe was something like this, but in 3 dimensions, and far more complicated. As the universe expanded, its temperature fell. The earliest moments are difficult to describe with certainty. Our current theories work extremely well in many regimes. But when we approach the earliest instant, physics reaches limits. We do not yet have a complete theory that combines gravity with quantum mechanics. So there is a boundary beyond which we cannot confidently describe exactly what happened. But we can follow the universe forward. Very early on, the universe was filled with extremely energetic particles. As it expanded and cooled, different particles became stable. Quarks combined into protons and neutrons. The universe became a strange cosmic environment, filled with radiation and matter. There were no stars yet, no planets, no galaxies, only a hot, expanding universe, slowly becoming cooler and more structured. Eventually, protons and neutrons began combining into atomic nuclei. The universe entered a period known as primordial nucleosynthesis. Hydrogen nuclei formed. Helium nuclei formed. Small amounts of lithium were produced. But the universe remained far too hot for stable atoms to exist. Electrons were still moving freely. Light constantly interacted with charged particles. The universe was opaque. Photons could not travel freely across enormous distances. Then, after hundreds of thousands of years, something important happened. The universe cooled enough for electrons to combine with atomic nuclei. Neutral atoms formed. The interaction between matter and light changed dramatically. Photons could finally travel through space much more freely. That ancient light is still with us. We call it the cosmic microwave background. It is one of the most important pieces of evidence for the early hot universe. When scientists detect this faint radiation, they are seeing light released from a time when the universe was still extremely young. Not the beginning itself, but a remarkably early chapter. The universe was already expanding, already cooling, already developing small differences in density, tiny variations, almost unimaginably small. But gravity noticed them. Where there was slightly more matter, gravity pulled more matter inward. That made those regions even denser, which strengthened their gravitational attraction. More matter gathered. The process continued, slowly. Over millions and billions of years, small differences became larger structures. The universe began building itself. But first, there was a long period of darkness. There were no stars yet, no galaxies shining across the universe. Only matter, radiation, and enormous clouds of hydrogen and helium. This period is sometimes called the cosmic dark ages. Imagine existing in that universe. There is no familiar night sky. Because there are no stars, there are no bright points of light scattered across the darkness. The universe is not empty. It is filled with matter, but it has not yet learned how to shine. Gravity continues working. Gas gathers. Clouds become denser. The first stars begin forming, and eventually, the universe experiences its first starlight. These first stars were probably enormous. They formed from material containing almost no elements heavier than helium. They were different from most stars we see today. They burned brightly and often lived relatively short lives. But their importance was enormous, because stars were about to begin changing the universe itself. Inside their cores, nuclear fusion created heavier elements. When some of those stars died, they released those elements into space. The universe became chemically richer. Carbon appeared, oxygen, silicon, iron, and eventually, the raw material for planets and life became increasingly abundant. The first stars were not just lights in the darkness. They were cosmic factories. They transformed the chemistry of the universe, and their deaths helped prepare the universe for everything that came later. Gravity continued gathering matter. Stars gathered into larger systems. Galaxies began forming. Some were small. Some grew larger through mergers. Over immense spans of time, the cosmic web emerged. Filaments of matter stretched across space. Galaxies gathered along these enormous structures. Clusters formed. Voids appeared. The universe became increasingly organized, not because anything planned it, but because gravity had been working for billions of years. Eventually, one of those galaxies would become our home, the Milky Way. But the Milky Way itself would take a long time to become what we know today. It would merge with smaller galaxies. It would form new stars. Old stars would die. Gas would move. Dust would accumulate. And somewhere within that enormous galaxy, billions of years later, a cloud of enriched material would collapse. The sun would be born. Earth would form. Life would appear. Human beings would eventually arrive. But we are not there yet. We are still looking at the young universe. A universe without Earth, without the sun, without humanity. And perhaps this is the most difficult part of the journey to imagine. The universe did not begin with the things we know. There were no mountains, no oceans, no trees, no birds, no cities, no rain. The rain itself belongs to a much later chapter. Water in its familiar planetary cycles required worlds, and worlds required stars, and stars required time. The universe had to wait. Stars had to live and die. Galaxies had to form. Heavy elements had to accumulate. Planets had to appear. And eventually, life had to emerge. The universe did not become complex all at once. It became complex gradually. A simple beginning, followed by layers of history, particles, atoms, stars, galaxies, planets, chemistry, life, consciousness, and eventually, a human being listening to rain. It is difficult to think of a more remarkable chain. The atoms in your body are part of a universe that began billions of years ago. The oxygen you breathe belongs to a universe that created stars. The water falling outside belongs to a planet that formed from ancient stellar material. The earth beneath you is one small world inside one galaxy, inside an observable universe containing enormous numbers of galaxies. And yet, you can sit quietly and imagine the entire journey. Perhaps that is one of the strangest abilities consciousness gives us. We cannot travel backward physically, but we can reconstruct the past. We can look at ancient light. We can examine ancient rocks. We can study fossils. We can measure the expansion of space. We can detect the cosmic microwave background. We can observe distant galaxies as they were billions of years ago. The universe leaves evidence of its own history, and we are learning how to read it. Tonight, we have followed that evidence backward, from the rain to earth, from earth to life, from life to ancient oceans, from earth to the birth of the sun, from the sun to ancient stars, from stars to the early galaxies, and from galaxies to the young universe. Now, we have reached the farthest point in our journey that current science can meaningfully describe. A universe only a fraction of its current age, hot, dense, expanding, simple, compared with what would eventually emerge. And perhaps this is where the story should pause, because after this point, our certainty becomes smaller. The equations become more difficult. The conditions become more extreme. And the boundary between what we know and what we still do not know becomes increasingly important. We do not know exactly what happened at the absolute beginning. We do not know whether asking what happened before the universe is even meaningful in the way we normally imagine time. We do not know whether our universe is part of something larger. We do not know whether there were other phases of reality before the hot, expanding universe we can observe. There are hypotheses. There are mathematical possibilities. There are competing ideas, but there is no final answer. And perhaps that uncertainty is worth keeping, because the universe is not required to reveal every secret. Some questions remain open, and perhaps that is part of what makes looking upward so fascinating. The night sky gives us answers, but it also gives us questions. The rain outside does something similar. It is simple, water falling through the atmosphere, and yet that water belongs to a history billions of years long. Everything around you is like that. The ordinary world is built from extraordinary history. The glass beside you, the air in the room, the water outside, the ground beneath the building, your own body, all of it belongs to the same universe, the same ancient story. And now, we are going to turn around. We have traveled backward for billions of years. We have reached the young universe. Now, slowly, we will begin coming home. The first stars will appear again. Galaxies will gather. The Milky Way will take shape. The sun will be born. The planets will form. Earth will appear. Life will begin. Forests will grow. Animals will arrive. Humans will emerge. Civilizations will rise. And eventually, the story will return to where we started. A quiet room, a rainy night, a person listening to the sound of water and thinking about the universe. So let the ancient universe remain behind us for a moment. The darkness slowly fills with the first stars. One light, then another, then another. The universe begins to shine, and our long journey home has just begun. The rain is still falling, and now we begin to come home. For billions of years, we have been traveling backward, past humanity, past animals, past the first life, past the earth itself, past the sun, past ancient stars, past the first galaxies, and finally, to the young universe. Now, we turn around. The direction of time remains the same, but our story begins moving forward again. The universe is young. There are no familiar galaxies yet. No sun, no earth, no oceans, no rain. But the first stars are beginning to appear. Small regions of gas collapse under gravity. The first stars ignite. They shine into a universe that had been dark for an immense stretch of time. Their light travels outward, across enormous distances. The universe begins to glow, and inside those stars, new elements are being created. The simple universe becomes chemically richer. Stars live. Stars die. Their material spreads through space. New stars form from the remains, and the cycle continues. Gravity gathers matter into larger structures. Galaxies form. Galaxies merge. Stars are born and disappear. The universe slowly becomes more familiar. Eventually, one galaxy begins taking shape. The Milky Way. It is not yet exactly the galaxy we know today. Its history will continue for billions of years. Small galaxies will merge with it. Gas clouds will collapse. New generations of stars will form. Old stars will fade. And somewhere within this enormous galaxy, a cloud of gas and dust begins to gather. The material is rich with elements created by previous generations of stars. Carbon, oxygen, silicon, iron, and many others. This cloud will eventually become something very important. Our solar system. About 4.6 billion years ago, gravity begins pulling the cloud inward. The material rotates. The cloud flattens into a disk. At the center, matter becomes denser, hotter, more concentrated, and the sun is born. A new star in an old galaxy. Around it, the remaining material begins forming planets. Rocky worlds appear closer to the sun. Giant planets form farther away. Asteroids remain. Comets remain. Fragments of the early solar system continue moving through space. And among the rocky worlds, one becomes Earth. At first, it is hot, violent, young, but over time, it cools. A crust forms. Volcanic gases enter the atmosphere. Water accumulates. Oceans appear. And the planet becomes a place where chemistry can unfold. The same universe that once contained only simple elements now contains oceans, minerals, atmospheres, complex molecules, and eventually, life. We have reached a familiar chapter again. The first organisms appear, tiny, invisible, simple, but persistent. They reproduce, they change, they evolve. Over enormous spans of time, life transforms the planet. Oxygen accumulates. Complex cells emerge. Multicellular organisms appear. The oceans become filled with life. Plants reach the land. Forests spread. Animals evolve. Dinosaurs appear and disappear. Mammals diversify. Primates emerge. Human ancestors appear. And eventually, humans. The entire cosmic journey has led us back here. But this time, we see it differently, because we know where it came from. The Earth is no longer simply the world beneath our feet. It is the result of billions of years of cosmic history. The water in its oceans, the rocks beneath its surface, the elements in living organisms, all belong to a much older story. The planet is a continuation of the universe, not something separate from it, and neither are we. Humanity emerges very late. We walk, we hunt, we make tools, we control fire, we migrate, we build communities, we create agriculture, we create cities, we develop writing, we begin recording history, and eventually, we begin studying the universe itself. We look at the stars and discover that they are suns. We discover galaxies. We discover that the universe is expanding. we discover that light travels at a finite speed. We discover that looking farther into space means looking farther into the past. And eventually, we realize something extraordinary. The universe can be studied from within. We are part of the thing we are observing. The atoms in our bodies were created by cosmic processes. The planet beneath us formed from ancient stellar material. The sun is one star among enormous numbers of others. And our galaxy is only one galaxy among countless galaxies. Yet, for all its enormous scale, the universe eventually produced a small world where consciousness could appear. And that consciousness can listen to rain. So now, the journey is almost complete. The universe has become galaxies. Galaxies have become stars. Stars have become planets. Planets have become worlds. Worlds have become environments. Environments have produced life. Life has produced minds. And minds have begun asking questions. The rain continues, but perhaps you can imagine it differently now. Each drop falling outside belongs to an ancient planetary cycle. Water rises, clouds form, rain falls, rivers flow, oceans collect, and the cycle begins again. The same basic water molecules can move through the environment for immense spans of time. The universe provides the ingredients. The planet rearranges them. Life uses them. And, eventually, they return to the environment. Everything moves. Everything changes. Nothing remains exactly the same. And yet, patterns continue. The Earth turns. The moon orbits. The sun rises and sets. The seasons change. Rain falls. Life continues. And somewhere in this enormous system, you are here, listening. For a moment, doing nothing. You do not need to understand every detail. You do not need to remember every date. You do not need to solve every mystery. You can simply listen. The rain, the distant sound of the world, the quiet room around you, and perhaps, somewhere behind those sounds, you can imagine the entire history we have just traveled. A universe beginning in an extremely hot, dense state. The first atoms, the first stars, the first galaxies, ancient stellar explosions. The formation of heavy elements. The Milky Way. The birth of the sun. The formation of Earth. The first oceans. The first life. The long age of evolution. The rise of humanity. And finally, this moment. One small moment. On one small planet. Inside one galaxy. In an enormous universe. The journey backward showed us how far the story extends. The journey forward shows us how many things had to happen to arrive here. And perhaps the most remarkable part is that none of it needed to be centered around us. The universe was not waiting for humanity. The stars existed without us. Galaxies formed without us. Planets formed without us. Life evolved without us. And yet, after billions of years, we appeared, not at the center, not as the purpose of the universe, simply as one late chapter in a very old story. Perhaps that is enough, because being small does not mean being meaningless. A single moment can still matter. A single life can still matter. A single rainy night can still be beautiful. The universe is enormous. Our lives are brief. But for a little while, the universe is able to experience itself through us, to look backward, to wonder, to remember, to ask questions, to listen. And tonight, we have listened to one of the oldest stories imaginable. The story of how everything around us came to exist. Now, let the story become quieter. The galaxies are far away. The stars are distant. The sun is hidden below the horizon. The earth is turning slowly beneath the night sky. The rain continues to fall, and the room around you remains still. The universe has traveled in almost unimaginable distance to arrive at this moment. So perhaps, for tonight, there is nowhere else we need to go. We have already traveled across billions of years. We have visited the birth of stars, the formation of planets, the beginning of life, the emergence of humanity, and now we are home, back on Earth, back beneath the clouds, back beside the rain, back inside this small and quiet moment. And as the drops continue touching the ground, the universe keeps moving. Stars continue shining. Galaxies continue drifting. Planets continue orbiting. Life continues breathing. And somewhere beneath the same sky, you can simply rest. The story can continue without you needing to follow every chapter. For now, just listen to the rain. The universe is still here, and you are here too. The rain is still falling, softly, steadily, and after traveling through almost 14 billion years, we are finally back where we began, here on Earth, a small world beneath a dark sky. For a moment, there is nothing else we need to understand. No equations, no dates, no distant galaxies, only the sound of rain. Perhaps you can imagine the planet from above, the clouds moving slowly across the atmosphere, the oceans hidden beneath them, the continents disappearing beneath the darkness. Millions of lights scattered across the night side. Somewhere, there is a small room, a window, and beyond that window, rain. The earth continues turning. It has been turning for billions of years, long before humanity existed, long before there were cities, long before there were people listening to rain. The planet was already moving through space. The moon was already beginning its long journey around it. The sun was already shining, and the universe was already carrying the story forward. Tonight, we are simply one small part of it. A quiet observer, a temporary presence, listening. Outside, the rain touches the ground. It runs along roads, collects on rooftops, moves through rivers, returns to the oceans, and eventually, it will rise again. The cycle continues, just as the larger cosmic cycles continue. Stars are born, stars die, matter spreads, new stars form, planets appear, worlds change, life emerges, life disappears, and somewhere, new stories begin. The universe does not stop, but you can. For a little while, you can let the story become distant. The galaxies can fade into darkness. The stars can become small points of light. The history of Earth can become quiet. Human history can become quiet. Even the questions can become quiet. Because you do not need to know everything tonight. You only need to rest. The universe is still moving, whether you are awake or asleep. The Earth continues turning beneath the clouds. The moon continues its orbit. The sun continues burning. Stars continue shining across distances too great to imagine. And the rain continues falling. Perhaps there is something comforting about that. The universe is enormous, and yet, for this brief moment, your world is very small. A room, a bed, a window, the sound of water, a little warmth, a little darkness, and outside, an ancient planet moving quietly through space. Think about the journey we just made. We began with a rainy night. Then we looked at Earth. We traveled through the history of life. We watched humanity emerge. We went backward, past the formation of Earth, past the birth of the sun, past ancient stars, past the first galaxies, all the way to the young universe. Then we turned around. The universe became stars again. Stars became galaxies. Galaxies became the Milky Way. The sun appeared. Earth formed. Oceans gathered. Life began. Humanity arrived. And finally, we returned here, to this moment, to this rain, to this quiet night. It is almost strange how small the ending feels. After billions of years, the story does not end with a great revelation. It ends with rain. Because, perhaps, that is exactly how it should be. The universe is full of enormous events. Stars exploding, galaxies colliding, black holes consuming matter, planets forming, worlds disappearing. But human life is made of small moments. A conversation, a sunrise, a quiet room, a hand held by someone you love, the sound of rain against a window. These moments are small, but they are the moments we actually experience. And perhaps that is why they matter. The universe may be unimaginably large, but we live our lives in small pieces of time. One night, one morning, one breath, one moment at a time. So let this be one of those moments. You do not need to follow the story anymore. You do not need to travel anywhere else. The journey is over. The universe can remain outside, far away, quiet, patient. The stars can continue shining without asking anything from you. The planets can continue orbiting. The galaxies can continue drifting through space. And Earth can continue turning beneath the rain. You can simply remain here, listening. The sound of rain becomes the last thing we notice. Not because it is the most important thing in the universe, but because it is the thing closest to us. And sometimes, the closest things are enough. The history of the universe began billions of years before this night. The history of Earth began billions of years before this night. The history of life began billions of years before this night. And somehow, After all that time, you are here, breathing, listening, resting, a tiny moment, at the end of an almost unimaginably long journey. The explosion that began the universe was not something we could hear. The birth of the first stars made no sound that could reach us. The formation of Earth happened long before anyone could witness it. The first life had no idea where its story would lead. The first humans could not imagine the world we live in today. And yet, generation after generation, the story continued, until eventually, there was this night, this room, this rain, this quiet, and you. Perhaps that is enough of a conclusion, not an answer, not a final explanation, just a moment of awareness, a small place where the enormous history of the universe and the brief history of a human life meet. Outside, the rain continues. The clouds move slowly across the sky. Beyond them, the stars remain. Some are young, some are ancient. Some may no longer exist in the form we see. Their light continues traveling through space, carrying pieces of the past. And perhaps, that is what tonight has really been about. Everything around us carries a history. The rain, the earth, the stars, the atoms in our bodies, even the darkness between the stars. Nothing exists alone. Everything belongs to something older. Everything came from somewhere, and everything is still becoming something else. The universe is not finished. Neither are we. But tonight, there is nothing you need to become, nothing you need to solve, nothing you need to chase. Just rest. Let the rain continue. Let the earth turn. Let the stars remain far away. And let the universe carry on with its ancient journey. While you remain here, quietly, safely, for a little while longer. The rain falls. The night deepens. The earth turns. And somewhere above the clouds, the universe continues unfolding. You do not have to follow it anymore. You can simply listen and rest. Good night.